So we're still in the pub.
Second podcast, first pint.
Yeah. Oh, first pint with alcohol in it, because we did take advantage of the alcohol-free to start with, didn't we?
We're trying a new protocol this time.
Hey, you flagging yet? Are you good?
Oh, ready to rock.
Yeah.
Yes, always.
Lee Davis and Gwilym Roberts are the two IPs in a pod, and you are listening to a podcast on intellectual property brought to you by the Chartered Institute of Patent Attorneys.
Should we just roll straight into this one?
Yes, let's.
So we've got with us, and I'll do my best to get your name right, Liz. Liz Zijing Li. Was that close?
Yes, amazing. Yeah.
Oh, thank you. So welcome to the podcast. We love it when we get inventors on because you've got the best story to tell. Gwilym's a patent geek, so he will properly grill you through all of the IP angles and the business angles, won't you? And
I'm heavily prepared for this.
And I'll be an interesting bystander this time.
As ever. Yeah.
So welcome, Liz. So good to have you here. So tell us a bit about you first of all. Who are you?
Yeah, really, really glad to be part of these IP kind of community. And for myself, I have a background of academic research and also business development operations. So now we are running a university startup company called Mimicrete. So we are a company providing sustainable and resilient self-healing concrete solution for the environment in a way that we're trying to make our building be more durable, sustainable, and resilient. So we have been going through a long way from the commercialization path, which is pretty much involved with all the IP concerns, and from the university to the startup, and then startup to the commercial world. So it's really kind of a central conversation about IP. So I'm really glad to share basically our previous experience and how we could maybe have a more kind of interesting kind of exploration also regarding this conversation. So yeah, that's me.
So Gwilym's going to absolutely kind of drill down through the IP stuff, but can you tell me a bit about self-healing concrete? That's a thing, yeah?
Yeah, so self-healing concrete, as its name, is self-healing. So make sure that concrete are able to self-heal itself when the damage appears. So if you think about human or any a natural creatures, we have the vascular system in our body. So when the crack appears, this will trigger our immune system, our vascular, to release the blood or liquid to heal the cracks or damage. So we're trying to actually use the same concept to bring self-healing function the same way into the concrete. So in our way, we are mimicking a self-healing vascular system, similar like our human body's circular system. So then when a crack appears, they will trigger the concrete to release the blood in the same way that our human body works. So that's how we call it self-healing concrete, using a vascular system.
So you don't need to put anything in after kind of production, after it's been used, to cause it to self-heal. Whatever it is that's making the magic work is in there, yeah?
Yeah, so in there we have a physical system. You can imagine it's like a polymer-based system that are adding on the top of the reinforcement, and then we pour the concrete in. So on the surface, you see no difference with any benchmark concrete, but the magic is the vascular system itself and the healing agent it contains. So when the damage triggers the vascular, they will actually release the healing agent and heal the crack automatically. So always as a self-monitoring procedure by concrete. So imagine the future that when we see the cracks, we'll see the building automatically heal itself. So this is how we're trying to bring the sustainability here for the
so
building.
we've just had some. I'm going off at a tangent now about concrete. Sorry, Gwilym. We've just had quite a lot of new sea defence work done around Portsmouth, where I'm from, and I think back 4 or 5 years now to one particular bit, Esplanade, where they'd kind of put a reinforced concrete wall around it to better prepare us for potentially rising sea levels. And within weeks, it started to show cracks. Yeah. And the guys were coming along and cutting big chunks out and kind of repouring. So that wouldn't happen. They would fix themselves.
It won't, because that's becoming a really kind of headache for the industry. So in the UK, that we've been spending around 50% of the whole construction budget just on repair replacement.
Really?
It's a lot of money, £30 billion, I remember from the last report. So for instance, when we see a crack in our critical infrastructure, what we normally do is to send developers to manually fix the cracks. And in 5 years, those cracks have to be fixed again and over again, which is a really costly procedure. And also, when it's coming to really kind of dangerous places, like in a nuclear plant or a dam or a tunnel, it's very dangerous. It's not really kind of it's really costly procedure. It's not really safe for actually people to access. So that's why we're trying to solve that problem in addition to only self-healing.
Wow.
So when it's the Hammersmith flyover, for example, that was closed for ages, wasn't it?
I don't know, was it?
Yeah, I think so. That's presumably a concrete problem. So yeah, even for kind of critical stuff, well, infrastructure critical, I could see that as well. I'd say a couple of kind of just interesting questions. I've interest about the actual product. So structurally, does it affect the strength of the material? Is it structurally effectively the same with the new system inside it, or does that make a difference?
Yeah, this is a really great question, because when we come to like concrete structure, the first thing we care about is that how are we changing the mechanical strength for the concrete? Is it weakening or is it improving? So we did a few like a laboratory and a commercial trial testing. So compared with the benchmark concrete, we could even like stay as the same or even better, because our vascular system, the designed way, is actually to also helping to distribute the load, which means to enhance the mechanical performance even up front and later stage. So this is like how we're become really kind of special and be able to add more value for the industry, because there are like other technologies available in the market, and also people are adding like other minerals or bacteria, so many amazing, fascinating things. But the only challenge is that how we could make sure even the damage appears and we heal it, can we achieve the similar types of strength? This is basically what industry are looking for. They don't want the concrete just be sealing like a decoration. They want it actually to be sealed and healed to have a good functionality.
So integrity is maintained.
Actually, it's been working. So this is what we're being added a value. So we're trying to even increase the mechanical performance after damage, and we're trying to also prevent water from penetrating through the cracks to further cause corrosion. So this is always like the whole package of the benefit we could bring to the industry.
Another mechanical-ish questions.
Yeah.
I think you described it as a vascular system.
Yes.
I do have that's the stupidest finishing question, Lee.
We'll
see how we go. Presumably there's something in that vascular system. So when you make the concrete, you've got that in there. Does that mean there's a lifetime attached to this? So there'll come a point where the vascular system is exhausted? How does it work?
Yeah, so basically we're considering how we're actually doing the life cycle maintenance of this structure. So currently we're under commercial trials. So we're doing like 2 parallel kind of testing to validate. So first you could see like in a lab, you could do accelerated testing to make sure that we are trying to accelerate the damage, to do cyclic testing to make sure that we collect those damage cycles and to see how much we could protect on the second hand. We're also trying to put more applications on site. So then we're collecting the site data and they will calibrate the data on site and also to feed in back to the simulation. So then we could have a more kind of into the real world kind of estimation to do like a life cycle kind of performance prediction. So this is what we're doing at the time being. And also this is pretty much what are the customer looking for, because they're caring about how much longer we could help the building to be able to survive and how much more cost we could reduce over the life cycle, and also how much carbon dioxide we're reducing over the life cycle. So this is like a whole kind of a life cycle assessment we're currently conducting.
How do you reduce carbon dioxide?
Yes, so there are 2 parts of carbon dioxide. So one part at the beginning is that we call it upfront carbon emission. So for instance, when we're using cement or like cement products, actually the manufacturing procedure of the cement is costing around 8% of carbon emission globally. It's really massive carbon emission burden for the environment. But then upfront, we're able to reduce some amount of the cement by actually adding our technology, because we're replacing the volume of the cement which is supposed to be in concrete. So we're reducing amount upfront. And the second part is a life cycle, because if we're doing replacement means we have to build a new kind of a structure again. So we're reducing this kind of life cycle carbon emission as well.
Cool.
In 2 parts.
It's so exciting, isn't it? Who knew you could get so excited about concrete?
And cement.
And cement.
And vascular systems, all at the same time. So I'm interested. So it sounds to me this isn't something you make up in the bath. This is something based out of a long study. What is your academic background?
So I was conducting my PhD degree in civil engineering, environmental area. So my main focus was to work on like a solution to make concrete be able to self-heal using 3D printing procedure or any other alternative ways to make it happen. So I was doing these like 3.5 years of research working on self-healing, like especially through vascular structure, through fugitive ink that we are trying to create hollow channels in concrete, or even to try to use 3D printing directly to make this sustainable structure. So this is my kind of a whole kind of PhD thesis. And it was really exciting, and I got so many inspirations and how things can be progressing even better. And in the lab, normally you're being constrained by the very perfect condition, because lab, you can control the components, you can control the process, control the testing temperature, humidity. But on site, this is like a wild scenario. Nothing is being can be comparable from the lab. So we have been developing so much different variations to try to adapt into the industrial commercial requirements, also adapting the operational procedure requirement, because we've been visiting so many different factories, and each factory has their own ways of manufacturing, different molds, different loading procedure. So we're learning all this process to try to adjust our technology to fulfill the requirements. So it's like a huge learning curve from the lab and to the commercial. It's like, it's a different world.
So cutting if I can just very quickly. So if a company takes on your product, do they need to do anything to their existing kind of systems and processes and molds or whatever they might be using, or are you simply replacing the product, the concrete, with a different concrete, so it's kind of one size fits all, they can slot it straight into their workflow?
We're trying to reduce the amount of variation for the client side. So what we're doing is that we're not changing any mold, we're not changing their components of concrete, we're not changing their operation. We fulfill our solution as much as we can to not making them change.
Yeah, got it.
So this is how the commercial, even for the partners who like to try our products, because if they have to do a lot of changing process molds, then it's so much effort and so much investment from their side. So it's going to be a big barrier for us as well. Yeah.
What's the market saying? Is there market interest in this?
Yeah. So we have a few market tractions across our value chain. So if you think about construction sector, it's all the way from asset owners, construction contractors, there are cement manufacturers, and there are all like precast concrete manufacturers. There's so many different sectors in the company, in the supply chain, that we're trying to fulfill individually with the value to them. So for instance, that now we're having a few tractions from the railway sector, that we're being currently conducting a site trial with GCRE, and also Network Rail, which is a new innovation rail station in south part of Wales. So we're deploying our technology on site together, being sponsored by them as well. And also we've been working on other side projects regarding water defense and regarding like highway scenarios. So we're already having a lot of tractions in the industry and also from like a wider community. So this technology being really kind of having the interest by the wider world. It's just a way of how we could make it quicker to be commercialized to the market.
I guess you've got your accelerated trials as well in terms of
Exactly.
which you're going to have to, the reason you're accelerating them so you can give the evidence that this is a long-term solution.
Exactly. This is a critical point, because for the site demonstration, this is critical resources for most of the new technologies, because if you do everything in the lab, even accelerated testing, it won't show anything because you're in a controlled environment. But in a site, basically you're validating by the real challenge and the real kind of environment. You're collecting the real data, and without this chain or without this procedure, no one's gonna buy your product, and you are not able to process when your certification. So this is like very critical part to be able to demonstrate, to have the validation by the industrial partner.
I got more.
No, keep going. Yeah.
So you've mentioned we quite a lot. You can tell us a bit about the team, because this can't all be you. Sure.
Yeah, because we always like to use the word we instead of me or like that, because the company or the concept is not only building by one individual, it's by the whole team. So we are really kind of lucky to work with like 3 female co-founders. So we are like a female leading team in the construction sector. So for myself, I'm having the background of a mixture of operation and technology. So I'm operating the company in this way. And our CEO has a pure background from business. She is a serious startup founder. And my CTO, who has been in the same research group as me before, like 15 years experience in technology. So we're in a really good matching to make things happen. And I would believe we're a great team to make it work.
Totally, a little bit tangential, but that's quite unusual in construction, isn't it? To have an all-female team? No, is it changing?
I would say the trend is actually changing, but majority of the time that if we are arranging meetings or meeting like having the industrial workshops or like a larger event, well, female is still like a minority, and also because I'm also part of the CIOB, which is the Chartered Institute building. So then they are having their kind of a report saying that still like females having the minority of the in the space, which is still kind of there's still a lot of space for us to improve to make female to be more having more exposure. So then, like, especially, I mean, for female engineers, there's a minority, but even for, if you think about female entrepreneur or female owners in the construction sector, that's even allowed like a more kind of a single digit percent. Yeah. So this is the scenario where we are, but I think the trend is becoming better because all of the exposure, all of these kind of support, and also people getting more used to this kind of hybrid working, especially combining with digitalization and side work, and they are more kind of enabling females to be able to work on a wider scope, which is in a really good shape in the future.
Cool.
Yeah.
Well, we had that. We've really interesting session on women inventors. And in particular, the incredibly low number of women-only inventor teams statistically. That was a really eye-opening.
Yeah, it is. Yeah.
And for me, inexplicable, but apparently our guest explained it perfectly clearly.
Below 4% from memory, wasn't it? It's really low. Really low.
It sounds really, really unusual. So who are the inventors? Is it mostly yourself and your CTO? Or?
So for the technology, I was an inventor, so I assigned technology to the company.
Mimicrete, sure.
And that's how I go through the whole process of the IP protection and learn how the potential thing we could make it wrong or we could be really in danger. So it's really kind of a good learning for us.
I was going to move to IP.
Go for it.
That's why we're here. That's why we're here. Yeah. So, how have you found the IP process? Has it worked for you? How have you gone about getting your patents?
Yes, I think it's really kind of foundation to understand what are patentable from the IP scenario, because like from what we understand from like the IP 101 courses from my IP attorney, and we learned that there are like a design where the design can be protected, the general the solution or applications can be also be patented, but then I think that the first steps actually is to, especially our technology was previously trying to reinventing from the research. So then we're trying to understand what are something that has to be put back into the university, because university has their own like a rights of the technology being used in the lab where we're being under the procedure, and also when we're moving to commercialization, how big the difference can we differentiate the IP from the work we did in a limited environment in the lab or the new creation that we've been conducting in the real world. So this is also like a second step. We're trying to evaluating the differentiation and what are patentable for the recreation version. So I think that's the critical part, that we have a lot of support from the IP attorney, which is fundamentally important for us to be able to understand what are patentable. And then under that, and once we confirm this scope, which is of course taking a long time of understanding the foundation, and then we move toward to the patenting procedure, which is the drafting process, because another is this opening another world in terms of what are available in the market, what are potentially available. So it's like defining the scope of the IP, which is also like I remember was also really challenging and interesting kind of exercise for me to be able to trying to, how do I say, it's not like a balance that you're trying to make the scope in a nice way that it could protect your technology, but don't go too far that are not protectable. So that was a lot of fun of us restructuring the scope over time.
So you've been running the IP yourself?
Yes.
That's really interesting. How have you found the support from the government, from the IPO, from the authorities?
Yes, that's a great point. So as a company, like for IP, especially for patent, is very expensive, the whole process. Like the UK patent, the process, and also the global patent is very expensive. So we're really lucky that we also get support from the UK IPO through also the collaboration with Innovate UK.
Yeah.
So Mimicrete, we were winning quite a few Innovate UK grants. So then we have a dedicated advisor to help us to navigate the potentials. That's how we're understanding the potential grant to help us for the IP. So we applied for the UK IPO grant to support us on the IP auditing as well, and also the original IP patent was taken from our own kind of pocket because we really need it before anything gets in. Yeah, so that's we did have some support, but then it just like the way that how things being structured, I think is really helpful for any startup company to use those resources.
It's interesting also talking about the funding there you've got from various government bodies, and there's a lot out there. Have you gone for investment at all? Is that an area you're looking for?
Yes, we did. So we, as a funding stage, actually, we closed our pre-seed around 2022 November. So it was around 350K from the investor perspectives, and also with a few kind of a government grant, which is we're receiving around 1.2 million-ish for the public grant, which is really helpful for technology to be able to be tested and also to be validated both in a lab and also to support the technical team to do more accelerated procedure. So it was really helpful. And also, as you mentioning, the fundraising from like the outside world is also challenging, especially for the time being. Like everyone is getting like the environment is getting more like relatively conservative than normal. So it's getting challenging, but we think that we're lucky that we raised our pre-seed round in good timing. And also we are being lucky as well to be able to secure some of public funding. So then we're able to still deliver and to still demonstrate our performance, to have a kind of tracking record of the performance.
I've got one more.
No, keep going.
Which is more out of interest. We meet many inventors. We're very lucky to do that, and they have different motivations. You're clearly highly entrepreneurial. Where does that come from?
That's a really interesting question, because I think for entrepreneurial mindset, it's basically not wanting to be restricted in a comfort zone. So I previously thought when I was doing my PhD or like before I starting this business, I was thinking that I might be working in academia as a lecturer or even to do consulting work, like classic consulting. So then I think it was just coming from like the opportunity that we have. So, like the Cambridge University, the engineering department was so close with Dutch Business School, it's just across the road.
Right.
So it's like, so normally we receive some kind of courses or support from, it's like a mutual kind of support. So I was really lucky to be sponsored by my supervisor. So she was really kindly to support me to join this program. So then I was taking the Dutch Business School courses for like 2 different like entrepreneurial programs there, and then I built up this kind of foundation to see like how different between like the laboratory ideas, how we move the idea into innovation. So, and then before I joined those kind of courses, I feel like it's challenging because it's like a blank canvas that you don't know what are the uncertainties. But then when I was starting to investigate, but also it's a community. Cambridge is also a really lively community that they have so many investors, so many professionals, so many financial expertise, so many like technology founders. They already navigated out through innovation, through idea to innovation. So then it's like a foreseeable track that you don't see that is so challenging. So then by having those support and information within the community, I feel like it's relatively, I think it's one step ahead to make this decision to register the company. So then I think that's pretty much how I make the decision. But then regarding like how I finally choose to be like an entrepreneur, I do believe that I find more passionate in creating something new or creating something that is really making the change. So that's like, I think it's the main motivation from in the inner side of myself. So I think that would summarize.
Well, the fact that while you were doing a PhD, you thought, I might just pop across the road and go to the entrepreneur school as well, is remarkable. But not every PhD is going to be commercializable. So did you choose your PhD topic maybe thinking that this could become commercialized, or is it just a lucky coincidence? Or
No, I haven't think about it, because I did my bachelor's degree and then directly go to my PhD because I was so dedicated and I want to be like in academia forever. Mm-hmm. That's why I choose this hard way without even a master, because people do a master to have a buffer time and then they can leave. I choose to do like a direct PhD after my bachelor's degree. So this is how I was so stubborn to want to go for academia. But then in the same time, when I was doing this laboratory testing and then all these things, amazing things I feel like it's been hidden in the lab. And there's so many opportunities outside that can make it even shining even in a better way. That's why I was really curious to have a lot of conversations with even the industrial seminars that the department's organizing. And they're seeing a lot of interest in the industry. We're already having like an innovation type of concrete, like carbon capture concrete or low carbon concrete. There's so many new technologies available that people having this kind of interest. So I was thinking, why this technology, self-heating concrete, cannot be commercialized in a market? That's why I started to navigate how things would work in a reality. And then coincidentally that they have this kind of program from George Business School, and that's how everything fell up together.
And where do you go next? Is this does this become a massive international conglomerate with kind of outlets all over the world? Are you going to license it out? What's the future strategy?
Well, the future. So we're aiming to, we're not only going to be concentrating on the UK market, we're also going to step into like EU or Asia market and US market as well, because we see like the global construction sector, like the biggest demand are always like the more developing kind of infrastructure. So we're also developing this whole kind of strategy to step into different kind of region. But of course, they require a lot of more consideration regarding the structures, regarding the resources, regarding the certification, how we could adjust technology to fulfill different demand by different market. So this is like a whole different topic. Like each individual market requires a new kind of investigation and a new kind of full-on research on the market. So then, so basically we're now at a stage of exploring the best market for the next stage. Of course, it's the EU, but also in the same time, how we could deploy our technology quicker once everything's demonstrated. So it's pretty much like on the stage of like planning for expansion, but also to enlarge our manufacturing capacity with partners. So this is like our next stage. Yeah.
We probably ought to give your patent attorney a shout out, shouldn't we?
My patent attorney, Joe from...
Kemps, yeah?
Yes.
Kemps.
Yeah. Oh, great firm. Shout out to Kemps.
Yeah. How did you pick an attorney? How did you find a patent attorney? How did that?
I think that's the magic of the Cambridge community, because they are also part of the community, and they're providing sessions for founders to understand how like the differentiation of different patenting ways or protection ways. So this is how we meet them, even through that the courses. And then right after I finished my PhD, we're thinking about commercialization, thinking about patenting. And then they are pretty much like the first person that we think about, because we knew them and they gave us like advice before. So
do you find that you get more value into the business than just IP? Is it a bigger relationship than that?
It is a huge benefit, not only about the protection of the founding the company, but also it's like a protection. I think it's two ways. So the first way is to be able to have the foundation to say that our technology are protected in some degree by the IP, by the patent, which is basically setting up the attraction for the investors. Because if a technology doesn't have an IP or doesn't have protection, then it's not investable. So this is basically the foundation, how we're able to get the first pre-seed round, because we have these protected. And second part is for commercial partners, where we're collaborating, which is always the big giants of the globe. And collaborating with them is really exciting, but also we need to be really careful about what we could protect on the way for the project. So by having this really solid patent and protection is giving us really good kind of protection at the beginning, and then we could also just deal with the single kind of few terms around IP. Then that's pretty much it.
And presumably, with your global aspirations, you can make use of the various international systems and so on to keep your protection open. So PCT maybe?
Yes, we already moved to the PCT application earlier this year.
Good.
Yeah. Good shot for that. It's definitely, it's basically our focus.
It's a good system.
Yeah.
It's a good system.
So we have a live audience, don't we, Gwilym? I wonder whether anyone in the room's got a concrete question they want to ask. Ian, you've got a concrete question. Shout it out.
I don't know anything about concrete, so I may be making myself look like a tech idiot. And apologies if it's been covered and I missed it. So what's being protected? Is it what's delivered or how it's delivered to a network of things? So what's the invention? Is it?
Yeah, I think this is a great question, because what we are protecting now is the vascular system itself. The system and the solution, and how this can be adapted into the different applications. So for instance, application depending on like a highway, railway, like different applications. So these are the protection. And we're protecting in a kind of solution kind of way. I mean, I'm not an expert in IP terms, so maybe it's not the right term, but what I'm saying is like the whole kind of solution, that kind of protection.
So is the whole network then, is that?
Yeah, it is.
That, so that's patentable? Or
it's
patentable.
designed, or? The design of the solution, but also how the material being used and how this can be connected to the different applications. So this is like the whole kind of, and even operational procedure. Yeah.
Thanks. Oh, keep going, Ian. Keep going.
And sorry, this is a real. So how do because they're probably quite fine, these delivery systems. How do they not just clog up?
Oh, sorry.
How do your veins not clog up? I think is it.
Oh, I see. This is a great question, because the first thing that when we're designing a vascular structure is to avoid blockage, but also providing more alternative routes. So we're kind of before we're basically diving into like the bio type of papers to understand how our human or like the plant vascular are able to avoid clogging, avoiding leakage. So this is a combination of concept of like of making the right angle, the right diameter, the right kind of whole package basically to make sure we're avoiding a blockage or avoiding leakage at the same time.
Neil, have you got a question? Shout it out loud enough for the mic.
There's some amazing stats around concrete and its damage to the environment. I think the concrete industry is responsible for something like 8% of global carbon emissions. So your invention has got this incredible potential to have an amazing environmental impact. In your wildest dreams, what do you think that might look like?
So from my perspectives, regarding especially for the concept of self-healing, we don't want only self-healing to be constrained by only giving the performance of concrete. We also want to make the self-healing that can be connected, that can be notified by the developers, so then they would know the real performance over time. So now we're only at the foundation of the performance, but also in the next stage and in the future, we want to make it more kind of a smart way to make people like everyone that could just looking from their panel like digitally on like in your devices and know and monitor the whole system, the building, and then know the health of the building in a real time. So this is like our future kind of scenario, but then it's needing more kind of a collaboration with different parties, different technologies to make the whole things together. It's like a whole kind of a concept about digital twin and also about the smart city.
So you're going to need partnerships.
Yes. Yeah.
It is dangerous asking the audience to.
Well, we've got two new podcast hosts over here.
Can I also just say people should check out Liz's IP story on our YouTube channel because she's
We'll make sure we put a little link on the podcast.
Is Ian back in? Ian.
So in terms of practical problem solving, so things like the rack in UK schools that weaken concrete, would that be a solution to things like that? You know, in the future, and like the bridge that collapsed in Italy, the Canary Bridge, would that be?
So that's a really critical question, to be honest, because we've seen like things like that, and schools and having this roof has to be enforced to close for a really long time. So that's been happening like a different material, and actually it's not being designed or built for the current usage. And we do believe that our solution can support on that, but normally for our technology are normally fitting with most of the new kind of element, but also we could replace the old element to kind of serve the new function. That can be supportive. So I think that's a really good point, that we have the potential to help on that. But regarding the current scenario, it's always about how we could balance out the resources and expense on how we could quickly maintain and make everything keep running again. So I think we do have the potential, but and also please also bear in mind that we're a small team and a relatively early stage before fully launch of the first product. So we're happy to do R&D and product validation with the organization, but to fully sell to the solution for now, I think we're a little bit early for that.
I'm going to stop any more questions from the audience.
Yeah, no, I'm intimidated. They're good questions.
Yeah.
The wrong places.
What's going on? You're particularly intimidated when your guest says that's a great question.
Yeah, that wasn't.
And you didn't ask it. Yeah.
I was actually just chuck in though. This is a really good example of where IP really helps, and it's when you've got these foundational, in many senses, technologies like this. You've got something completely new. You can have really strong patents sitting under that. This is not an incremental improvement. So that first patent you've got is really important. I'm guessing there's plenty more to follow as you continue to solve problems and so on.
Yes, this is so true, because now we're having this big umbrella to cover the scope as much as we could. And then under that, because normally we'll do some a new kind of improvement, is basically a small part of the big umbrella. So we could have the small kind of how do I say? I don't know the formal term, but it's like an additional small kind of pattern or small thing to attach on the top of this big the first pattern. So this is actually how we're gonna protect or follow up inventions across our solutions.
Okay. More importantly, was that a better question than they asked? You don't have to answer that.
Liz, we're kind of coming to time. It's been an absolutely fascinating conversation. Thank you so much for coming into the pub today and sharing that with us. But we always finish the podcast with a little bit of a friendly, fun, informal question. And did you indicate to me that you might have a question?
I'm regretting it now. I did, yeah.
So
we're talking about self-repair.
Self-repair, yeah.
And your body's obviously quite good at low-level self-repair.
Yeah.
But if a large part of you was cut off, which bit would you most like to be able to grow back?
Would it grow back in an improved way? Which bit would I genuinely got to think of a bit of my body I would cut off and grow back?
Yeah, grow back.
My head.
That's a really good answer.
Yeah.
I'll take that.
Yeah.
I'll take that. Okay, good. Liz.
I'm so laughing. Thank you so much for inviting me, and I was even still kind of having this kind of impact from your last question was really good.
Good. So she's avoiding you.
She's avoiding that.
Very sensible, yeah.
Come on, mate. Which bit are you going to cut off and regrow?
Well, my bum.
Why?
Well, I want to sit down, relax. Otherwise you spend the whole time standing up.
Would you grow it in the same place?
That's a really good question. Let's do a swap. I'll put my bum back on your head, and I'll finish the sentence.
So if you've listened to this podcast and you've really enjoyed it, well done for getting to the end. So please leave us a review on the podcasting platform of your choice, and that means that more people will find us and more people can listen to Willem grow his bum back.